Today we revisit an old friend, a nice friend, square roots. Remember square roots? Square roots, right? What's the square root of 9? 3, right? Why is the square root of 9 3? Why is the square root of 9 3? Right, because 3 times 3 is equal to 9, right? So squaring a number and square rooting a number are opposites of each other. So if we want to list the perfect squares, right, isn't 1 a perfect square? 1 times 1 is 1. 4 is a perfect square because 2 times 2. 3 times 3. 4 times 4. Can you keep on going? Right? You can just generate these for yourself, right? 81, 100. After 100, sometimes you got to think about it. Oh, right, 144, 169, 196. 196. Doesn't want to write. 225. Right? So those are the perfect squares. Now we're going to use those perfect squares to simplify square roots that are not perfect squares. So square root of 20, you remember this, right? Square root of 20 can be written as the square root of 4 times the square root of 5. And the square root of 4 is 2, so the square root of 20 reduces to 2 root 5. Similarly, the square root of 45 reduces to 3 root 5. That was a 9. So square root of 9 is 3, and square root of 5, I don't know. When you get to one like 48, people think, oh, 8 times 6, but neither of those are perfect squares. 4 times 12, you could do 4 times 12, but then you'd have to end up reducing again. Even better is 16 and 3. So 4 root 3. If you did 4 and 12, just to show you, if you did root 4, root 12, 2 root 12, then you can simplify the square root of 12 to root 4, root 3, and the square root of 4 is 2, and 2 times 2 is 4. So it's just like a little bit longer process to get the same answer. Square root of 600, square root of 100, square root of 6, 10 root 6. If I put a number in front, that's okay. It's just a number in front, right? Root 9 root 2, 7 times 3 root 2, or 21 root 2. You should actually already be pretty good at these. You might feel like, I don't even need to show all this work, right? I could just say, let's say square root of 4 is 2, 2 times 10 is 20, and just go right to the answer would be fine. If you're multiplying, you're going to multiply the outside numbers together, and then the inside numbers together, and then, of course, simplify the square root of 20, root 4, root 5. Square root of 4 is 2, so it's 20 root 5. Number 8 can sometimes get people. I would just do what? Whenever you square something, it means to multiply it by itself. So this is 36 root 49. Come on. Or 36 times 7. And so 2 carry the 4, what's that? 252? Yeah, 252. Perfect. Okay, so now we are on to adding and subtracting square roots. You can only add and subtract when they're like terms. None of those look like they're like terms until we simplify them. So here, So here in 3 root 20, we could make it 3 root 4 root 5. 3 root 4 root 5. I just want to write here. And square root of 4, of course, is 2, so that's going to turn into 6 root 5. And then here, 5 root 45. Well, square root of 9 is 3, so this is going to be 15 root 5. And then the square root of 75, of course, is 5 root 3. I can only add together the like terms, which are these two terms, so I get 21 root 5 plus 5 root 3. And those are not like terms. What am I going to do in number 10? Right, distribute. So I get 12 root 3 minus 8 root 2. So minus. What am I doing in number 11? Right, FOIL or double distribute. 4 minus 2 root 3 plus 2 root 3 minus the square root of 9, which is 3. Right? So 4 minus 3 there is 1 minus 4 root 3. Here, let's see, I'm going to have 2 minus root 7. I'm going to have to write that 2 times, right? 2 minus root 7 times 2 minus root 7. So whenever you have a quantity squared, you just want to write it 2 times. 2 minus root 7, 2 minus root 7. 2 times 2, of course, is 4. I'm going to have inner and outer terms that are the same. And my last term is going to be the square root of 49, which is 7. So my final answer, 11 minus 4 root 7. Great. Okay, last thing, dividing square roots. You might remember what is not allowed in the denominator. You're right, a square root is not allowed in the denominator. So we multiply top and bottom by the square root of 7 to get the square root of 49 in the denominator, which is 7. Here, when you have a 2, you just need to multiply by root 5. So I'm going to get 7 root 5 over 2 times 5, because square root of 5 times square root of 5 is the square root of 25, which is 5, and 2 times 5 is 10. You've done those a lot. 15 and 16, these might be a little new, or you did them in algebra and people sometimes don't remember how to get rid of a radical expression. It's a radical expression when it's got, 2 terms really in the denominator. So we're going to multiply top and bottom by what we call the conjugate. Conjugate is just going to change the sign there from a plus to a minus. In the numerator, I don't distribute that just yet. I like to leave it in case it cancels. You'll see what I mean. At bottom, I have first, outer, inner, last, right? The last is 3. Those are going to cancel out. So it's just going to be over 1. So I can leave my answer really the 6 times the quantity 2 minus root 3, or I can distribute it. But I kept it just in case it would have canceled. Last one, multiply top and bottom by the conjugate, which is 1 plus root 3, 1 plus root 3. Now this one's a little bit crazy because I get a first, outer, inner, and last that are just all different there. That's a 3. And then the denominator, 1. Now if you want to just like not do the outers and inners because you know they're going to cancel out, positive root 3, negative root 3, that's fine. And then the last term is minus 3, so it'd all be over negative 2. The bummer about this one is that nothing in the numerator really combines, so it's all over negative 2. All right, so we'll practice more like this. I would say like one like number 15 is really important. You'll definitely see it on the quiz and test, and so make sure you practice those on the homework. Square roots.